Welcome back to the shop and to the channel. Well, last week in the shop I made this brass nut for the riser that clamps the pivot for my micrometer stand. Well, this week I'm back in the shop and I want to start working on the jaws for the little mini vise that's going to be used to clamp the micrometer. Well, I want the vise to be softer than the micrometer, so I picked up this bar of aluminium off of the eBays. Well, I need two pieces about the same size, but I think I'm going to end up changing some of these dimensions, so I think I'm going to cut off a couple of pieces that are a little bit larger than what this print is calling for. So I'll take it over to the bandsaw and we'll cut out a couple of chunks. I have a couple of pieces now off of the end of that bar. They're not very square, they're square-ish. And I really want to clean up some of these faces. They don't have to be perfect, at least not yet, but I would like to try to square these up or at least make them a little more reasonably square over on the Bridgeport. Well, I've got this 2-flute end mill mounting in the Bridgeport that's got a really nice long cutting face on it, so I should be able to take off material off of the sides of these in one single pass. Rather than using like a facing mill on the top, I want to go ahead and edge machine these. Well, I'm going to set one of these pieces on the left side of the vise and then the other one on the right side just to even out the clamping forces on the vise. I just want to clean up each of these faces with the end mill just to make them sort of flat. They don't need to be perfectly, smooth, but they need to be at least flat. I'm not making this to size just yet. I'm just trying to clean up this material. Well, that's good enough for this side. I'll loosen the vise now. I'm going to just take this part and rotate it 90 degrees and clean up an adjacent face. Well, I'll keep doing this on each face of each part until I get all 6 faces of both pieces at least machined flat. I'll finish machining the rest of these off camera. Well, with these machined at least reasonably square, I can now start on some of the finished machining operations. I have these pieces blued and laid out with some layout lines here to cut a couple of corresponding notches in each part. Well, in this part here, I'm going to remove this lower material and I'm going to leave 600 thousandths of material at the top. But in this part here, I'm going to take out 600 thousandths. Both of these are 875 thousandths deep so that when the material is removed, they will fit into each other perfectly. So I need to head over to the Bridgeport again and we'll start machining out these features, but I'm going to be taking considerable more care in accuracy. Well, I'll start with the fixed jaw of the micrometer vise. I've got it clamped into the mill vise. The first thing I want to do is find that right edge of the piece of material. Well, I'm only interested in the right edge and the top of this part in order to accurately remove this large bit of material in this corner. I'm going to use this 3/8 high-speed steel 4-flute end mill. I think that should give me a good finish on this aluminum. I want to accurately find the top of this material, so I'll use a piece of paper here and slowly bring up the knee until the end mill whips it out of my finger. I now know I'm about 3/1000ths of an inch away from the surface, so I can bring up the knee now until I just see the end mill start to make a mark. I'll use a little WD-40 as a lubricant, coolant, and we'll start whittling away at this about 100,000 step to cut at a time. I'm not going to machine all the way to my finished dimension here in the x-axis. I'm going to leave about 25 to 50 thousandths to take off in a couple of finishing passes. Well, I didn't cut all the way to depth to my 600 thousandths depth. I want to leave a little bit here for some finishing passes and to take some measurements. So I think I'm probably about 75 thousandths away from that 600 thousandths mark. I'll take a quick reading here with a depth micrometer, see how we're doing. It looks like we're at 535. You got to remember to read these depth micrometers backwards. So yeah, I got about 65 thousandths yet to go. Well, if I hadn't zoomed the camera in so far, you might actually be able to read this and see that I'm about 75 thousandths away from my target dimension in the opposite direction. I really want to hit these dimensions as accurately as I can, so I'm going to sneak up on these. I'm only going to take another 25 thousandths off of each of these faces. I'll take another couple of measurements here, and then we'll slowly start to whittle this down and sneak up on these dimensions. Spot on dimension here, and for this dimension we're at 875 and maybe a tenth, so that's perfect. And for the depth here we are 600 thousandths and maybe a tenth or two. That's perfect. With the notch in the fixed jaw finished, now I'll go ahead and start machining the corresponding notch in the dynamic jaw. This time I'm going to rotate this part 90 degrees so I can take advantage of the x-axis power feed. Well, in this orientation, the critical dimensions are the z-axis again, of course, but it's the y-axis this time that I need to hit a very specific mark. Well, I'm going to start roughing this out here. I think I'm going to be a little bit more aggressive than I was when machining the fixed jaw. I think I can take some deeper depth of cut and maybe even speed up my feed rate a little. Well, with this part oriented the way it is, I can use a micrometer here to check the dimension of the material that I'm leaving, because that's the important dimension here. Is I want to leave 600 thousandths of material rather than concentrating on how much I am removing, at least in this axis. And I've got quite a ways to go. Well, I still need about 54 thousandths of material to come off in this dimension. And it looks like I got about 20 thousandths yet to come off the back. Well, about a half a thousandth over 600 is not too bad. And, to be honest, that dimension isn't all that critical, but I'm just trying to get it as close as I can. When I put these two together, these notches, they fit together exactly where I want them to, and this will make a little bit more sense as we continue with this machining. There's probably 100 other ways to do this, but this is the way that I chose. I put these two vise halves together. The notches fit well, but you can see that the overall dimensions of each of these halves is not perfect, and that's fine because now I'm going to start machining these together as one piece. So now I'm going to take some super glue and I'm going to glue these two pieces together by the notch, and this will hopefully ensure that any shared features that get machined or need to get machined in both halves are in the same spot. And it'll also give me a chance to machine the overall dimension of the vise to where it is the same in all directions, and I only have to do it once. Well, to start machining this thing, I know the front of it and the back of it are flat-ish, so I want to set it in the milling vise here with those surfaces up against the dynamic and fixed jaw of the mill vise. Well, I have a larger end mill in the spindle now, and I know I can take up to about 100 thousandths off of this face. Right now, I just want to clean it up. I'm just going to take about 50 thousandths off. I just want to get it flat. I'm not looking at trying to get this to final dimension just yet. It's a quick deburr with a file, and we'll rotate this and clean up the remainder of the faces. Well, based on my drawing, I can take about 100 thousandths off of each of these left and right sides, as well as the bottom, as you're looking at it here in the video. Well, but looking at these dimensions, I actually might not take off that full amount. I might end up revising the drawing here and adjusting these a little bit in making this thing a little bit larger than what the drawing has. You know, sometimes when I draw these things up in CAD, they look good, on the screen. But if I don't make a 3D print of it, I sometimes am not really sure how this is going to turn out. And this is kind of one of those cases where I didn't 3D print it, and now I'm second guessing, a number of my dimensions. So I think I'm going to leave this a little bit bigger and then revise the drawing. Yeah, so I ended up leaving this thing about 350 thousandths wider than I had originally planned, which again I think is fine. It's not going to make this thing too big. I originally planned on 1 inch, but now that I'm feeling it in my hands, maybe, the larger size is better. Well, with the two Vise halves now machined to an overall size, I can start laying out for some shared features that are common to both halves. Well, these two halves do blend in with each other, so I want to make sure I maintain some level of orientation and mark which way is actually up. There's going to be one hole that will be drilled on the center line. In the fixed side of the jaw, it'll be threaded 1/4 20, and in the dynamic side, it'll just be a clearance hole. And then I've got a couple of other holes identified here that'll be for some guide pins, which realistically are probably completely unnecessary, but I'm including them anyway at this point, partly because I've gone down this road this far, so I might as well see it through. I'll start by drilling the two holes for the guide pins. I will drill these all the way through. I'm going to start with a drill that is 11/64, which is just 1/64 under 3/16 of an inch, which is the diameter of the guide pins. I'll follow that up with a 3/16 reamer, but I don't need to go the full depth, so we'll only go in about an inch. That should be plenty. And I'll repeat that same process for the other guide pin hole. Well, and in the spirit of game time decision making, I'm going to move the position of this hole for the vise screw about 60 thousandths higher than I originally intended. I've got a number 7 drill here in the chuck. That is the tap drill size for a 1/4 20 thread. And while I'm here, I want to drill the clearance hole in the dynamic jaw of the vise, which means I only want to go in about 600 thousandths of an inch. Well, I think it's okay at this point to take these apart. So I'll use my little handheld propane torch to put some heat on the aluminum. And from what I understand, that's all I need to get the super glue to release its bond. Well, I put the fixed jaw back into the mill vise on the Bridgeport just so that I can use it to help guide this tap down into that center hole. Well, while I have this part in the Bridgeport, I'll relocate the holes for the guide pins and we'll drill these out so that it's a sliding fit between the vise jaw and the pin. Well, for the dynamic jaw of my little micrometer vise, I can set these pins into the holes that we reamed. These should be a nice, comfortable press fit. The first pin went in nice and easy. Let's hope we have the same results with the second. That doesn't feel right, and that's because this is not going in straight. And now how do I get it out of there so I can fix it?
Not even straight.
I got a piece of pipe here out of the scrap pile and a smaller pin, and it should let me push this pin out, and hopefully the hole hasn't been damaged. That would really, really suck. Well, luckily that didn't do any permanent damage. It hadn't seated in there too far. So we'll give this another try. I've got this old gauge pen that I'm going to use to drive this in, and this will at least help me see if it's lined up a little better than trying to see it under the ram of the arbor press. Okay, that didn't go too bad at all. It's looking good so far. Let's see how it fits in the other half. Well, hopefully everything here will line up, and when I slide these pins into their mating holes, that these two halves of the vise will come together. I've got a 1/4 20 socket head cap screw just to test the alignment there. Everything seems to be still where it's supposed to be. Now get a little preview of how this will work. Put a micrometer in here, and when I clamp these two halves together, it'll hold it in place. Unfortunately, this 1/4 20 screw is too short, so I can't actually clamp it together. Hopefully, when this is all said and done, this will actually work. Now, looking at this thing in the real world, I kind of wish I would have made these jaws taller. They're only 1/2 inch, and I think maybe 3/4. Might have been a little bit more appropriate. I don't know. We'll see. But what I do know, I think that's going to be it for this video. I've just run out of time in the shop for this week. So if you like the video, give it a thumbs up. Your comments are always appreciated. I do read them all. If you're not a subscriber, I would appreciate you hitting that subscribe button. And that's it for now. Thanks for watching. We'll see you on the next one.